Hello, here we will discuss about standard deviation. As we know, once we are talking about measures of central tendency and measures of dispersion. In measures of central tendency, when we'll calculate mean, so we need to calculate standard deviations. With mean and standard deviation, we can report together. So mean tells us the average value of given data set and standard deviation gives the scatteredness of the data set. So here we will discuss what is standard deviation, how we'll calculate for group data and how we'll calculate for ungrouped data. So these two group and ungroup, these 2 points need to understand. So let's discuss about standard deviation. What is standard deviation? We need to find out. So standard deviation is the most important measures of dispersion, and standard deviation is the positive square root of the mean of the squared deviation from their mean of set of observations. Standard deviation is the square root of variance, means once we are writing standard deviation this sigma, so we can write this under root sigma square. So square root of variance is known as standard deviation, and the square of standard deviation is also known as variance. So this is the standard deviation. Once we'll do the square, this is known as the variance. So this is the basic information about standard deviation. Now we'll discuss if x1, x2, x3 up to xn be a set of n observations or values, then the standard deviation is expressed and defined as, so standard deviation for sample, we can apply this formula, we can notation, we can write the s, which is under root summation I equal to 1 to n within a bracket xi minus x bar whole square divided by n minus 1. And once we'll calculate the standard deviation for population, so standard deviation which is noted by the sigma under root summation I equal to 1 to n xi minus x bar whole square divided by n. So basic difference for standard deviation for sample and for population, here denominator would be for sample n minus 1 and for population would be the capital N. So this is the basic difference in a formula we need to remember. Let's have one example, we can get more clarity. Suppose calculate the standard deviation for given sample data. So sample data is given. So and this is the ungrouped data. So we need to calculate the standard deviation. So try to understand here how to calculate. As we know, in given data set, observations is given, and with help as per requirement of the formula, we need to calculate xi minus x bar. So xi is, this is the xi, and mean we have to calculate. So here summation x bar, as we know the formula, x bar equal to summation xi divided by n. So we need to add all the values, which is sum of is the 128. So 128 and total number of observation is 8. So we will get this value, and once we'll divide, so x bar value is coming here 16. So that's why x minus this 10 minus 16 will get this, 12 minus 16 will get minus 4, 14 minus 16 will get minus 2, 15 minus 16 will get minus 1. So like that we can subtract and we can find out xi minus x bar. As we know the formula of the standard deviation, this is xi minus x bar whole square divided by n minus 1. This is the formula. So for that we have to square the value. So we'll get, once we'll square minus 6 whole square, we'll get 36, minus 4 whole square, we'll get 16, minus 2 whole square, we'll get 4, minus 1 whole square, we'll get 1. So we'll get this value and we'll add this, we'll get 130. Why? Because here we need a summation I equal to 1 to n xi minus x bar square, which is 130. Here n is 8 minus 1. So 130 divided by 7 here. And once we'll calculate this value, we'll get this value 4.3095. So a measure of the average is scattered around the mean. So standard deviation is 4.3095 and mean is x bar is 16. So we can find out the standard deviation for ungrouped data. This is the simple way for calculation we need to understand. Now we'll discuss for standard deviation for group data. So for group data, as we know, whenever in a data set, if data is given in a group and its a frequency is given for each group, then for will then how will calculate the standard deviation? We need to apply the again formula standard deviation for sample. Yes, sample for will give the notation yes summation I equal to 1 to n fi within a bracket xi minus x bar whole square in denominator n minus 1. So here just basic difference for group and n group. Here we are just multiplying the frequency here. And for uh, population standard deviation, we are using same formula, only denominator is going to change, it's a capital N, and we have multiplied the frequency. So formula is same, only we are multiplying the frequency. That's for the group data. So this is the formula. Now we need to understand how to calculate the standard deviation for group data set. So suppose for example, we have a group data set, systolic blood pressure is given in different group 9 to 100, 100 to 110, and for each group frequency is given and total frequency is given is a 68. Then how will calculate the standard deviation? This is a little bit difficult, but we'll try to simplify here. So let's have this example. Already we are aware, if we see the questions here, in a question this column is given already and frequency is already given, these 2 points is given, but we have to remember the formula. So for that formula, in formula we require the xi column, so we have to find out the xi column. For xi, we have to take the average value, lower limit plus upper limit divided by 2 will get 95. Same way we have to do for all, like here 170 plus 180 divided by 2 will get 175. So now we have got the 175. 5 according to formula we have to find out xi minus x bar. So we need to calculate the x bar here. So x bar equal to summation fi xi. So here xi column is given and fi is column is given. We have to multiply corresponding value, 3 multiply 95, 5 multiply 105, 7 multiply 115, 10 multiply 1 to 5. Like that we have to multiply all the values, like 2 multiply 175. So we'll get one column which is the known as the fi xi. Then we have to add all the fi xi value, which will get the 9220, and n is given. N means summation total frequency column here. So we have to divide by 68 and we'll get the mean x bar value is 135.6. So now we have obtained already x bar. Then we have to subtract xi, which is xi 95 minus 135.6 will get this value. So this 105 minus 135.6 will get this value. Again 115 minus 135.6 will get this value. Like that we have to subtract all value here. 175 minus 135.6 will get this value. Once we'll get the xi minus x bar column, then we have to square all the value minus 4 0.6 square will get this value. We have to square this value, then we'll get this value. Likewise, we have to the each values square, each number square, 39.4 square will get this value. So now, because we are talking about the group data, standard deviation calculation for group data, so we'll have to square this value xi minus x bar whole square. And as we know the formula for the standard deviation for group data, see here fi multiply xi minus x bar whole square. So we have xi minus x bar whole square column, and we have a frequency column here. We have to multiply all the corresponding value, like 3 multiply this 1648.36 will get this value. So accordingly we have to apply all the values, these and these, like here 2 multiply 1552.36, then we'll get this value. Then we have to add all these values, this summation fi xi minus x bar whole square will get this value. So as we know the formula, this formula we have to apply for the standard deviation calculation for group data. Then we can put the value here. This value we take from here. This is the this one, and we are talking about the sample. This is the sample data. That's why we are taking n minus 1 sample formula for standard deviation. Then we'll put the value here, same value we are talking here, and then we have to calculate it here, 68 minus 1. So once we'll calculate this value, we'll get under root this value, and then again we'll solve, we'll get the standard deviation here 1.984. That means for this given group data set, x bar is 135.6, mean is this, and standard deviation 1.986. So we can say mean value of given data set is 135.6, and scatteredness of the data set from the central value is 19.84. So this is the basic steps for calculation of the standard deviation for group data. It's a simple steps. If we are doing the stepwise, we'll get more clarity and we'll get accurate answer. Here we are going applying the traditional methods. This is the traditional methods. Manually we are calculating, but we want to calculate the standard deviation through software. We'll just put the value in the software and run the command directly. We'll get the standard deviation, this value. So this is the basic steps. Now we'll need to understand advantage of standard deviation. What are the advantage? So it is, as we seen, it is rigidly defined. It is less affected by sampling fluctuations. It is useful for calculating the skewness and kurtosis and coefficient of correlation and coefficient of variation and so on. We can use the standard deviation, and it measures the consistency of data. So this is the advantage of the standard deviation. Now what are the disadvantages of standard deviation? It is not so easy to compute. It is little bit difficult, the calculation method. So many columns we have to create, as we have seen, and it is affected by extreme values. Some values is more extreme, so it may results may affect. And now what is the use of standard deviation, where we use it? So this is the important point. So as I said, it is useful for calculating the skewness, kurtosis, coefficient of correlation, coefficient of variation, and so on, and it measures the consistency of data. So this is the important points for standard deviation whenever we are going to talk about the measures of dispersion. Under measures of dispersion, absolute measures, and in absolute measures, as we have discussed mean, as we have discussed range calculation for group data, ungrouped data, mean deviation for group data and ungrouped data, and standard deviation for group data and ungrouped data. One more quartile deviation will discuss. Thank you.